So our first task, bringing up the internet network, that was a pretty big one. There was a lot of stuff that we went through, a lot of different nuancy things, and had a lot of fun digging deep into BGP capabilities. Now, the next couple tasks are going to be a little bit on the lighter side, but they're still big, important, and fun. So now that we set up the internet backbone and network, the next step, we're going to move down just a little bit and focus on the MPLS backbone network. So we're just going to give this the base configuration, connectivity in place, and then make sure that MPLS is up and running in this particular video. Let's get going. All right, what's up, everybody? It's time to tackle lab task number 2, which is going to be all about bringing the MPLS backbone to life. So in the previous task, we brought the internet backbone to life. Now we're bringing the MPLS network, or the MPLS service providers backbone to life, before we move on to the customer devices and all the other things that we need to do. So before we get started, first, huge shout out to CBT Nuggets for, of course, helping me get all of this done and set up. If you're following along and these items feel fuzzy to you, that's what CBT Nuggets is there for. That's where you go to get trained first before you attempt to tackle all of these items. In particular, since we're talking about building the MPLS backbone, which will become an MPLS Layer 3 VPN, you'll want to check out our ENARSI content. On the ENARSI exam, Keith Barker goes really deep into MPLS and MPLS Layer 3 VPN. It's where I learned how to do it. So huge shout out to that, and definitely recommend it. So let's take a look at the tasks that we have here. I'm going to jump into lab tasks and then MPLS network. So we got a small amount of tasks this time. We've got 9 tasks, and we're building some OSPF. And looking at this, we're doing step 2, configure the OSPF domain to accurately calculate the costs. So that's going to be auto cost reference bandwidth. R2, R3, R4, and R5 should not send hello packets out interfaces that are not connected to R1. So R1 is in the center here, and we've got 2, 3, 4, and 5 on the outside. We don't want to send hello packets outbound towards our customer edge devices. We've got some authentication tasks between step 4 and step 5. Advertising the loopbacks of each device. Doesn't give any specifics on how to do that, if it should just be an advertisement or if it should be redistributed. Configuring BFD to detect a failure after 3 seconds. So you're actually configuring BFD timers and intervals there. Configuring OSPF v3 on IPv6, and then enabling MPLS. So pretty easy steps here. Of course, the Layer 3 VPN is where it's going to be more challenging, but that's going to come several labs from now. So let's bring up the consoles. I'm going to bring up R1 here, and here's what I'm going to do. We're going to do the same thing as before with a little split screen action. Cool. I'll thumb this over a little bit so we can take a look at it. Cool. Now we've got R2. Oh, too many 2s. Get that. Bye-bye. There we go. 3, 4, and 5. Let's take a lay of the land. We'll do enable, and I've got my quick button here so I can do show IP interface brief, excluding assign and administratively down. So all of the MPLS network is connected via 172.16. Then router 1 to 2, router 1 to 3, 1 to 4, and 1 to 5. Makes sense. And then this 2931, if I kind of move this over here to the side or down a little bit, that's actually what goes up to this border router, which is going to take us into the sd-wan territory, but we're not too worried about that right now. So the primary things we're going to be working with here are 172.16s. All right, well, let's get the lay of the land on the other devices real quick. Privilege mode. There's the IP addresses here. We've got our 192.169s. So that's going to be the edge nodes connecting to the customer edges. The customer edge MPLS networks are 192.169. The internet networks are 192.168. Let's do router 3. Privilege mode. There's the addresses there. Nothing too surprising here. We've kind of already seen it with router 1, but you can see the last octet is going to be matching the router number. And then, as we could probably imagine what router 5 is going to look like, enable, and there's the interfaces there. Cool. All right, so without further ado, let's get this thing started, right? Okay. Configure OSPF 12.34.5 between all routers in the MPLS area. All right, router OSPF 1. Let's say, do a pretty big network statement here. 172.16.0.0.0.255.255. So it's going to grab all of these 172.16s, and we're going to put it in 1234.5.0. Cool. Now, we had a requirement on step 3, do not send hello packets out that are not connected to R1. So as I move over to R2, I'm looking at my IP addresses here. I also need to configure passive interfaces on my OSPF instance. So let's do router OSPF1. Let's say passive interface default and no passive interface on the link that connects to router 1, which I'm looking at the little topology here. All of these devices connect to router 1 on E00. So I can say E00. Cool. Now we'll bring up the network statement 172.16.0.0, 0.0.255.255, 1.2.3.4.5.0. In fact, forgot the area. Let's do this. Bring up Notepad. We're going to say config T, router OSPF 1, passive interface default, no passive interface Ethernet 00, network. I hit tab just then. 172.16.0. Muscle memory, right? Area 1.2.3.4.50. Okay, cool. Copy paste. Boop. And boop. And boop. Okay. Let's watch these adjacencies come to life. We can do debug. Oh, well, too fast. I was going to do debug and just watch the packets, but oh well, too bad. All right, R1 should use HMAC authentication to connect to R2 and R3. So here's how I'm going to do this. We're going to start by building the key map, keychain, on R1. So let's say keychain, what do we want to call this? How about HMAC? Something simple like that. We're going to say key 1, key string. What do we say the key string needed to be? Did it care? Doesn't care what the key string is. We'll just call it Cisco. And we have to specify that the cryptographic algorithm is SHA-256. HMAC SHA-256. So if I do a do show run section key, there we go. So what I'm going to do is I'm going to copy this over here, paste that in. And now I'm going to configure this on my interfaces for R1, which is E00 and E01. So let's do exit, exit, and over here I'm going to do the same thing. I'm going to say exit, exit, and I'm going to say interface Ethernet 00, and I'm going to say IP OSPF authentication, IP OSPF, not key, authentication keychain, Cisco, no, HMAC. Okay, so let's copy this, paste, this, paste, and this, paste. So I should be able to copy and paste all of these configs on R2 and R3. Let's exit out of configuration mode. Okay, and then let's do the same thing for R3. Exit out of configuration or router configuration mode, paste everything in. Exit out of this. Let's actually end and do show IP OSPF neighbors. Let's actually clear IP OSPF proc. Yes. And cool. Came right back up. Ah, no, it did not. Show IP OSPF interface brief in await status. Show IP OSPF neighbors. Oh, you know what? I didn't apply that to the other interface, didn't I? Interface Ethernet 01. And where'd my notes go? Come back here, notes. Let's add the authentication to interface 01, which goes out to R3. And let's watch this come back to life. And two-way druther. Debug. Ah, man. I keep trying to do debug, and it's too slow. Okay, so HMAC SHA is done. We're already done with 1, 2, and 3. Time to move, 1, 2, 3, and 4. Time to move on to step 5. We're blowing right through this one. R1 should use MD5 authentication to connect to R4 and R5. It's a little bit different this time. Again, it doesn't say what the key string needs to be. Let's go to Ethernet 02, right? That's what my interfaces are, going to R4. Yep. So we're going to say IP OSPF authentication, but this time we have to specify message digest. And now I can say IP OSPF message digest key. we got to give it a key number like 1, and then the actual MD5 hash or string. I'm just going to put Cisco here. So let's copy these. Let's say IP OSPF authentication, and I'm not going to make the same mistake as last time. Watch this, watch this. Hang on. Okay, we're going to copy this. We're going to go to, now this other interface here on R1 is interface Ethernet 03. I see the neighbor adjacencies going down now. And now we're going to go to R4, interface Ethernet 00. Boop. And on R5, wait, do debug IP OSPF adjacency. Do debug IP OSPF packet hello? No. What is it? I'm never going to remember this. It's fine. Mismatch authentication. It's telling me mismatch authentication, and that's okay. Exit interface. I'm wasting too much time just playing with debug. Let's just add the authentication here and watch it come to life. Come on now. Oh, it's already got it done. Do you show I missed the loading statement? Oh man, look at that. Yep, it came up when we missed the loading statement in the debug output somewhere. Okay, well, do undebug all. Okay, so there, we've got 1 through 5 now done. Advertise the loopbacks of each device into OSPF. You know, I got a hunch that we're going to need to advertise all of these interfaces, including the edge interfaces too, the 192.168s. And since we've got passive interface disabled, I don't have any threat of actually advertising the interface. Because, I mean, when the MPLS network comes up, R5 is going to need to know how to get to the remote interfaces on R4, right? That's going to be important. We're going to need to know how to do that stuff. So let's bring all of the interfaces, including the loopback interfaces, into OSPF, especially since I have passive interfaces on. There's no threat in actually configuring the network statements here. So I'm going to say 192.169.00, 0.255.255, area was 12.34.5.0. And then, you know, before I do this, I'm going to grab that network statement because we'll be able to apply that everywhere. Paste it here in my handy dandy notepad. Then we'll throw in the 2.2.2.2, 0.0.0.0, area 123450. Cool. All right. Now we'll go here, router 3, router OSPF 1, boop, network 3.3.3.3, brain fart area 123450. 5, router 4, I should say, router OS, I can't type. Paste in my network statement, network 4. I tried to do it with my wrong finger. I'm trying to get fancy over here and it's not working. Zeros across the board, getting those loopbacks and those remote interfaces, 123450. And router 5, router OSPF 1. Get my network statement, 192.169.00.0.0.255.255, area 123450. I know it doesn't say to advertise those 192.169s, but I know MPLS Layer 3 VPN is coming, so I might as well bring those interfaces into OSPF so the remote routers can connect to them when it comes, when it's time to do that. And that way they can, you know, label switch those remote edge networks over there. And because we have passive interface on, it's not going to be advertising hellos out those interfaces, so there's no risk in just bringing them into OSPF now. 5555.0.0.0.0, area 123450. Okay. Do show IP route to OSPF. Let's take a look at what we got here. Looking good. Oh, router 1. Forgot the loop back on router 1. Exit router OSPF 1 network. 1.1.1.1, 0.0.0.0, area 123450. could probably make a similar argument about, you know what, no, I'm not going to mess with the route that's going up to SD-WAN because that's going to be in a VRF. So when we get to SD-WAN, we'll come back to router 1 here and handle that. So the loopbacks and the remote interfaces are now advertised in OSPF. Devices should leverage BFD to detect a failure after 3 seconds. All right, this is going to be fun. So on the interfaces, we need to enable and configure the BFD intervals. The big thing here is it says the failure should detect the failure after 3 seconds. So the BFD interval needs to be 1 second each, and after 3 failures, the multiplier of 3, after 3 failures, that's when it detects it's down. So on R1, we're going to do interface range Ethernet 00 through 3, and now we're going to set the BFDs on it. So BFD interval, this is done in milliseconds, so we're going to say 1,000 milliseconds, which is 1 second. The minimum receive rate we're going to accept is 1 second, and the multiplier, how many failures do we need to have? We need 3 in the interval of 1,000 milliseconds to detect a failure of 3 seconds. Cool. So the BFD configuration takes, well, the BFD configuration is there, but it's not actually sending BFDs because we haven't activated it in OSPF yet. So let's fix this on interface Ethernet 00 of router 2. Interface Ethernet 00, paste it in here on router 3. Interface Ethernet 00 on router 4, paste it in here. And interface, config T, interface Ethernet 00, paste it in here. So now we've got the BFD configuration set, and now we have to turn it on, jump back into OSPF configuration, and BFD is all interfaces. Boop, there it goes. Now we do have to have BFD configured everywhere, otherwise it's going to fail out on us. And BFD all interfaces on router 2. BFD is a two-way street. Have to have it in 2 directions for BFD to take effect. OSPF, router OSPO, oh my gosh, OSPF 1. How many ways can you spell OSPF? BFD all interfaces, and router 5, OSPF 1, BFD all interfaces. Let's watch it come to life. There we go. So BFD session created, BFD session up. BFD is now up and running. Configure OSPF v3 for the IPv6 interfaces. All right, let's start with router 1 here, and we should probably consider saving this config. So is it router OSPF v3? Give it a process ID of 1. And you know what? I'm not going to do anything right here. I'm just going to go to interface range Ethernet 00 through 3. And we're going to say OSPF v3, process ID 1, area ID. Is that right? No, IPv6 area. Did I even turn on IPv6? Unicast routing. Show IPv6 interface brief. Yeah, we got IPv6 interfaces. They're showing up, and there's the addresses. So, okay, we're in the interface range. So I'm going to say OSPF v3, process ID 1, IPv6, area 1234550. And I'm just going to copy this config right here. Set it on Ethernet 00 here. Boop. And I'm going to go into Ethernet 00 here, paste it in. Paste it in here. Oh. And on router 5, paste it in here. So those adjacencies do show IP v3. Okay, I see my interfaces are up. There we go. There's those loading statements. And there we go. We see the exchanges starting on router 4 and router 5 now. The loadings are coming up. So OSPF v3 is now enabled, and I've got the neighbor adjacencies coming to life. The final step, step 9, enable MPLS between all routers. Okay, very easy to do that. In global config mode, MPLS IP. And then under the interfaces themselves, let's go in router 1. We're going to do interface range 00 again through 3. E00 through 3. MPLS IP. Back to interface Ethernet. I think I'm already on interface Ethernet 00 on these things, but we need to exit out of that. Turn MPLS on globally. 00 MPLS IP. Router 3. Exit MPLS IP globally. Interface Ethernet 00 MPLS IP. Router 4. Exit out of this. MPLS IP globally. Interface E00 MPLS IP. And router 5, exit out of this. MPLS globally, interface E00, MPLS IP. There we go. All right, so we've got the neighbor adjacencies up. Yep, across the board here on router 1, I see 2, 3, 4, and 5. The neighbor adjacencies are up. If I do show MPLS forwarding table now, look at that. There we go. Look at all those labels. So now we have label switching to all of these paths, which is pretty cool if you ask me. Yeah, I'm happy with this. Okay, so that does the trick for our task number 2 of MPLS network before we move on to layer 2. That's going to be the next task. So again, thanks for watching this. Don't be afraid to like, comment, subscribe below, and check out CBT Nuggets learn.gg/data Knox. If you're having any issues with some of the stuff that we're covering here and struggling, that's where you can go to get the training on this. All right, thanks for stopping by, y'all. See you in the next one.